Hey everyone, welcome my dear students to 90 Plus My Tuition app. Do you know about the game football? Okay, let's watch a game then. Did you observe the movement of the ball? We found that the ball was not moving in the beginning of the match, right? When the match kicked off, the ball started moving on the field along with the movement of the players. What is it called? It is called motion. What did we understand from this? Yes, we understood that we can perceive an object to be in motion when its position changes with time. This is a direct example of motion of an object. But can we define motion by using an indirect evidence? Okay, fine, let us check it. Wow, the nature is beautiful. Have you ever observed the movement of trees while traveling in a bus? The roadside trees appears to be moving even though they are stationary, as you see here. In the other way, the passengers inside the bus sees his fellow passengers at rest even when the bus is moving. Hey guys, I'm gonna travel all the way to Bangalore. Have you ever felt like your train is moving even though it was stationary? I hope at least some of you might have experienced this. What is the reason? When another train moves along the nearby track, the motion of the other train makes us appear to feel like even though our train is moving. So, this is a perfect example for an object which may appear to be moving for one person and stationary for some other. So, do you want to learn more about motion? Okay, let's go, and that's our new chapter, motion. In this chapter, we shall first learn to describe the motion of objects along a straight line. Now, let's learn to describe motion through an example. Suppose a friend of ours called as Raju wants to travel to a shop from his house. Let's assume that the distance from Raju's house to the shop is 3 kilometers. Here, we have specified the position or the location of the shop with respect to the house, right? So, what is the significance of the house here? In this case, we have considered the house as the reference point to denote the distance to the shop. Is it just the house which we can consider as a reference point? No, we can also choose other reference points according to our convenience. Therefore, to describe the position of an object, we need to specify the reference point called as the origin. It is a starting point or a point considered to calculate the distance to a point. Now, let us consider our friend Raju wants to go to 3 different shops. Let us assume it as a textile shop, medical shop and a sports shop. We can represent it like this as you see here. How did we represent it? Here we have represented it based on the movement of Raju along a straight line, assuming that the shops lie on a straight line. We can consider Raju's home location as the origin and let's denote it as O. Now, let us assign a letter for each shop. We can denote the textile shop, medical shop and the sports shop as C, B and A respectively. What do these denotations indicate in this representation? Here, A, B and C represents the position of the shops at different distance values. So, imagine that our friend Raju travels from his house to the textile shop first, that is C. Then he will move to the medical shop, that is B. And finally, he will go to the sports shop, that is A. But Raju was confused whether to buy some more clothes or not. Yes, he gave a thought and finally he decided to buy some more clothes from the textile shop. What he will do then? Yes, Raju will travel back to the textile shop from the sports shop along the path of the medical shop. So, based on the representation given here, Raju traveled from the origin O through C and B and reached A. Then Raju went back along the same path and reached C through B. So here what will be the total path length covered by Raju? We have already studied that the total path length is the total length or the distance covered by an object. Based on the representation, we know that the total path length covered by Raju is OA plus AC, that is 60 km plus 35 km, that is equal to 95 km. What is this value? Yes, it is the distance covered by Raju. So, in this case, the total path length covered by Raju to travel from his house to the shop is the distance. Here, we got the value as 95 kilometers, and that is the magnitude of distance. I hope you all know that the numerical value of a physical quantity is its magnitude. Now, from this representation, can you find out the displacement from Raju's house, that is the initial position O, to the final position C, that is the textile shop? So, this difference will give you the displacement of Raju's path. Here, it is from O to C through A. By the way, what is displacement? In general terms, the shortest distance measured from the initial position to the final position of an object is known as displacement. In this case, the distance from Raju's house to the final position C, that is the textile shop, is the displacement here. So, in this case, the displacement value is 25 kilometers, that is the distance from the origin O to C. Before we go to the next topic, let's check out this question. That is, can the magnitude of the displacement be equal to the distance traveled by an object? Let's consider the Raju's path length representation for this. So, if we refer to the movement of Raju from his house to the textile shop, that is from O to A, we get the distance value as 60 kilometers. What will be the displacement value? Yes, it is also 60 kilometers. So, we got the magnitude of displacement and the distance value same here. Will it be the same in every case? Okay, let's check it. Now, imagine that Raju is traveling from his house to the sports shop and comes back to the medical shop. Then, what will be the distance value? Yes, it will be the distance from O to A plus A to B. That is OA plus AB, that is equal to 60 km plus 25 km, that is equal to 85 km. Then what will be the magnitude of displacement? Yes, it will be 35 km. Why so? Since in this case the initial position is O and the final position is B. Thus, the magnitude of displacement is not equal to the distance value here. Did you know there are some other cases where the displacement value is 0 and the corresponding distance value is not 0? Okay, let's check such a case then. Imagine that Raju goes to the sports shop and comes back to his house. Then what will be the distance value? Yes, it will be OA plus AO, that is 60 km plus 60 km. That is equal to 120 kilometers. But in this case, the initial and the final position is the same, which means that the shortest distance from the initial position to the final position is 0. That is, the magnitude of displacement is 0. Thus, we learned about two different physical quantities, that is, the distance and the displacement. What is the significance of these quantities? These quantities are used to describe the overall motion of an object and to locate its final position with reference to its initial position at a given time. Now, let us check the comparison of these two physical quantities using the table shown here. Here in the table, we can see different points regarding the difference between the distance and the displacement. From the table, let's discuss the first point, that is, distance is the total path or the complete path traveled by an object, As we have seen in the case of Raju, the total path length covered by Raju is considered as the distance. Similarly, we consider the shortest distance between the initial and the final position of an object undergoing motion as displacement. My dear champs, keep a note of this. That is, the distance will always be positive since we can't measure the distance value with negative integers, and the displacement can be positive, negative or zero based on the different contexts or cases. Then the next point is distance is a scalar quantity whereas the displacement is a vector quantity. I hope you know that scalar quantities are physical quantities which are completely described by its magnitude, which means no other information is required to specify them apart from the magnitude. Don't forget that a vector quantity has both magnitude and direction. Did you know distance doesn't decrease with time, whereas the displacement can increase or decrease with time? We have observed this in the example of Raju. You know what? Distance is never less than the displacement value. Then, will the displacement value be less than the distance? Yes, the displacement value is either equal to or less than the distance value.